Hey folks, thanks for joining me. I went and dug another little small Emerson receiver out. I think it's a 588A, if I remember correctly here on the back. And that is correct, according to the back plane. Looks like part of the antenna coil is protruding out. Let me see if I can get this thing repaired in short order and just clean up the case a bit. And the tuning condenser is seized up. Let me pull this thing apart, see what it looks like inside. Interesting little note here. Not sure what's going on here with the antenna coil. Little 5-tuber, probably just a simple All-American 5 superheterodyne. Flip this thing over and see if anyone's been underneath it. You see how basic this particular receiver is. Very few components, not much to it. Let me get this antenna coil removed, get it out of the way. The antenna coil, a better look, definitely very interesting. The tuning condenser is stiff as can be. I'll have to check into that more. Let me take some time, look online, see if I can spot a schematic for the unit real quick. A quick look inside the case or the cabinet, and you can see the licensed under the following U.S. patents and your typical little diagram for the tube locations. As you guys can see, the old antenna coil has had better days. I'm going to go ahead and break this thing apart and take a look at the backer itself and see if I can understand the primary and secondary winding configuration. It's easy to calculate the secondary winding that will be part of the tune circuit. I'll break that down in just a bit, show you a formula that we can use to calculate the needed inductance. So guys, just based on my limited research, I think this particular model was maybe more rare than some of the little Emersons. Again, at 50B5, the power output tube, the 12BA6, the first IF amplifier, 12AT6, the Diode Detector, the first audio frequency amp and A.V.C, and then the 12BE6 serving as the Oscillator and Modulator. And it has a half-wave rectifier, which was common for these particular chassis, 35W4. To start off the restoration, I'm going to tackle the B+ power supply first. You can see the old dual cap. You can reference the schematic as well here. A 30 and 50 microfarad capacitors, what's called out. You can see the one connection point here very easily coming from the cap back over to the 1000 ohm resistor. Brown, black, red. Then just for giggles, I think I'll hook it up and see if we can read any capacitance whatsoever. And the ground connection itself going back to the chassis for this particular receiver. And as you can see, it's probably the original E-cap back from the 1940s. Just what I expected to find. You can see the one section reading 521 or so nanofarads, so 0.5 microfarads, so very little capacity left, and 166 at 0.16 microfarads. So completely useless, and another great example why you never want to power one of these things up as well. There would be no filtering, and who knows what else would happen. And as you can see, that resistor needs to go as well. called out at 1000 ohms, reading 1266. So the math is real simple on this. It'll be 26.6% high. As you guys can see, I've got the B plus side of the circuit complete for the most part. Do have another resistor here, number 24, I believe it is. Should be reading 39 ohms. It's reading right at 48, so it's a little high and above 20%. I'm going to leave that for now, since the line voltage will run higher than back in the day. I don't think that's going to hurt anything, so I'll just denote that, and if it causes an issue, we'll come back and address that. The other thing I want to look at real quick, I'm going to just kind of work right to left, will be the resistor here across the oscillator coil. As you can see on the schematic, that's called out at 22K. Let me hook up across it, and you guys can see in circuit it's reading about 24 and some change. So just a bit high. I think I'm going to leave that for now, and then I'll address that one as well if it's an issue. The one that would really be suspect would be the 15 meg that ties back over to the A.V.C line. Let's measure that and see what we have. And as you guys can see, I've cut the lead so we can actually measure the DC resistance accurately. And we're about 18.8 meg. If I attach that back, and you can see in circuit, it drops down to 3.82. So it's a good, 25% out of tolerance. Let me see if I've got that resistor, and I'll go ahead and swap that out. Unfortunately, I don't have that value. I can probably put a couple resistors or multiple resistors in series to get the DC resistance required. So I'll just denote this one as well, and we'll come back to that if the receiver is not operating correctly. Just get that out of the way so we can move down here and get another one of these caps replaced. By the way, I've got the bypass cap replaced and put a X1, Y2, and it's placed down here. And let's give this 3.3 meg resistor a check. They're typically way out of tolerance as well. And you can see it is 4.34, so a good, 25% high. I do have that value, so we'll get that swapped when we replace the 0.1 microfarad cap as well. Okay guys, a little more work done here. I've got the 3.3 meg resistor replaced in the A.V.C string. And then you probably can't see it well, but down here on the audio side, another 15 meg resistor as well, which is in tolerance. It's about 12% high. So I'm going to leave that. And I'm going to move over here, get this other cap out, check these other few resistors. And we're getting closer to applying power for the first time. And we'll know right away if this thing will play again. What appears to be another out of tolerance resistor. You can see I'm reading about 734,000 ohms. Should be 470K. Let me knock one lead loose here. Just make 100% certain we're not getting anything from what appears to be a capacitor. Okay, definitely on the high side. Let's get this one replaced. And I'll go ahead and take time to get this old capacitor out as well. I think the schematic was 220 picofarads, and you can see I'm reading about 151. She plays again, guys. One thing I did find, someone had done a repair and where the diode filter resided, you can see tied back to pin 6 in the schematic. The 220 picofarad capacitor was missing. I've just got one tacked in on a temporary basis, actually using a 250 that I've got on hand at this location. But the receiver seems to be performing pretty well. Again, the oscillator tracking and the antenna trimmer would need to be adjusted once I address the antenna issue.
Peaceful souls, they carry whatever pressure and
I'm going to say, he probably has around roughly $800,000 in assets. So
Sure.
We'd want to have roughly about $450,000 per ton. So,
you can see I still don't have the dial cord back on. Just manually tuning the tuning condenser running through the band.
of everything. I mean, we got singing, got Bishop heads on it. It's just, it's for it. Stop, you never stop. You never stop. You never stop.
Canada more than once here this hour. They
So pretty cool to get this thing playing again. I've got to throw on a new line cord and again get the diode filter put in place that was missing. And I'm going to just double check through the schematic. And I've got to address the antenna that you guys saw. It kind of fell apart. I may try to rewind this antenna coil, or I may just use the ferrite antenna. Time will tell. Just need to ponder on that just a bit more. Then I'll address the cabinet here in the upcoming weeks as we approach the springtime. Put some stain on it, just clean it up a bit, and maybe put a coat of poly instead of lacquer on the cabinet as well. Appreciate you guys watching the simple repairs on this Emerson 588 Alpha. Take care. Stay well.
income actually would jump up to over $49,000, $49,213. So that's pretty good.